Good day. I hope you're all good and I hope you're all well. Welcome to Yebo Tutor live stream help on this beautiful Monday. So today we'll be doing analytical geometry, and bear in mind that we are now preparing for our final exams. So I would highly advise that if you have many questions, don't hesitate to join the WhatsApp group in the description of this video so that we can be able to assist you 24 hours a day, anytime, any moment, and you'll be able to receive the material which we give to other students. If it's a returning subscriber, thank you so much for continuously watching us on live. I hope everyone is ready, and I hope you have your pen and book ready for the day. And bear in mind that you have access to us, can ask us any question on our comment section anytime, any moment. You can stop me through your comment, or you can call us via Zoom so that we can actually interact with you and we can be able to assist you with no time. Okay, great. So now look, we are doing 2021 November 2021. So this question paper is quite um, challenging, and if you've been saying, last week we were doing paper one, we did functions and calculus. On Tuesday, Monday we did functions, then on Friday we did calculus. So this week we're gonna do paper two, we're gonna do and we're gonna cover analytical geometry, and I hope by Thursday we're also gonna cover Euclidean geometry. So without wasting much time, as you can see, this is November 2021 paper two, and today we say we're gonna do analytical geometry. So if you need like a few background of analytical geometry, I would highly advise that you go and look on the videos which are already been recorded, because bear in mind that now we are preparing for the final exam, so we are attacking many question papers as possible. So if you want the overviews, you can check them on the video. You can just click on the YouTube channel, then you can be able to find the videos and they can be able to assist you. Great. Just to give you a quick overcap or a quick overview right now, I want us to look at the important things which I'm going to be using or to be talking about today. So the first thing which I want to look at is the distance formula. So the distance between 2 points, is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. Then the second one, we will be able to calculate the gradient of the line, which is illustrated by the small letter a, and the gradient of line AB will be equal to y2 minus y1 or divided by x2 minus x1. Then the 2.1, I'll have to have 2.1 now in order for us to determine the x coordinate of the gradient. The easiest way we can do that is just by using what we call xm is equal to x1 plus x2 divided by 2. Then if we want the y coordinate, ym will be equal to y1 plus y2 all divided by 2. Then after that, number 3, we'll be able to calculate the midpoint between 2 points. So it's going to be x1 plus x2 divided by 2, as well as y1 plus y2 divided by 2. Then you'll be able to get your midpoint of the line. And also moving forward from now, number 4, so we'll be asked to calculate the angle of inclination. So in order for you to be able to calculate the angle of inclination, you must know that the formula is easy. Tan of theta is equal to the gradient of the line. So always know that this is the way we'll be able to calculate the gradient and also the angle of inclination of a line. Then moving from that point, the fifth one is that in grade 12 we were introduced to two of the important things, which is two formulas. The one where we are looking at the center centered at the origin, which shares the formula x squared plus y squared is equal to r squared. Then the next one, number 6, when we are looking at the center, not centered on the center, so the equation will be x minus a all squared plus y minus b all squared equal to r squared, where a and b are the coordinate of the center of the circle. So this is now the circle geometry which is introduced in grade 12, and we must always know that when we are multiplying the line, the radius multiplied by the gradient of the tangent, they are always equal to -1 because they are perpendicular bisectors. So now in the concept of today and everything which you're covering today, you must be able to apply those theories. And also what I would highly advise is that always know that the the shapes which were taught in grade 1, grade 2, they're important. You must know the characteristics of a parallelogram. You must also know the characteristics of a square. You must know the characteristics of a triangle so that you can be able to use those characteristics and answer the questions. Analytical geometry is best because you must be able to analyze the question and conceptualize what you are being asked so that you can be able to get correct answers. So without wasting much time now, let's look at our question number 3. So on question number 3, let's read together. Question number 3. So on question number 3, in the diagram, A, which is -2 to 10, and we are also given B is K is to K, and C is 4 is to -2, are vertices of triangle ABC. Line BC is produced to H, so we can see that line BC is produced to H and cuts the x-axis at E12 is to 0. Then also moving from that point, we are also told that AC intersects the x-axis at F and G respectively. The angle of inclination of line AB is 81.87 degrees. So as we were saying on our small overview, is that it's so important, it's so crucial for you to be able to understand the terminology of analytical geometry, because when you understand the terminology of analytical geometry, you're able to understand and unpack the topic as a whole. So for instance, now we are highlighting the fact that we are given the angle of inclination of line AB and it's equal to 81.87. So that fact is going to lead us directly to be able to calculate the gradient of line AB, even if we are not given two coordinates of A and B, because we already know that the angle of inclination is 81.87. That gives us now the go ahead to use the equation tan theta is equal to the gradient M. So now going to the question, calculate the gradient BE. Where is BE? So we can see BE is on this side and it's 2 marks. So how can we calculate the gradient of line BE? How can we calculate the gradient of line BE? We know the coordinates of E, which is 12 is to 0, but we don't know the coordinates of line B. So how are we going to calculate the gradient of line? So firstly, we know, and that's why I said initially that it's so important, guys, to analyze your question, because if you don't know how to analyze your question, you won't know what you are supposed to do and when you're supposed to do the right thing. All right, now let's get to it. Let's get to it. So question 3.1. Question 3.1. So what do we know about the line BE? Okay, we know that the gradient between B, C, and E, they are equal to each other. There is what we call collinear coordinates or collinear points. So that is supposed to lead us to the right method of calculation. All right, so let's go now. Let's calculate now. So we know that firstly that the gradient of line BE is equal to the gradient of line CE, and we know the equation of calculating the gradient, that it's y2 minus y1 over x2 minus x1. So from that point now, we are now looking at the coordinates of CE, because now we were able to see that. So it's going to be 0 minus 2, O divided by 12 minus 4. Then 0 minus 2 is equivalent to positive 2. Then 2 over 8 will give us 1 over 4. So then therefore the gradient of line BE is equal to 1 over 4. Then you get your full 2 marks. Just like that, you get your 2 marks. So what was important in this question is to understand that we have what we call collinear points, and the gradient of line BE is equal to the gradient of line CE. So since we are not given the coordinates of B, still we were going to be able to calculate the gradient of line BE using the coordinates of C and the coordinates of E. Now moving forward to the next question. The next question says calculate the gradient of AB now. So in line AB, what are we given? In line AB, we are given something so sweet and something which is on point. So we were told that on 3.1.2, we were told that the angle of inclination of line AB is equal to 81.87, and we know that in order for us to calculate the angle of inclination, the original formula says that the gradient is equal to tan of theta. So in this case, what is our gradient? Our gradient is gradient of line AB, and now in this instance we are given theta, so automatically we're just going to have tan of 81.87. 87. Then we use our calculator to get the correct answer. So I'm using my calculator. Please use your calculator as well so that we see what will be the gradient of line AB. So this was almost straightforward. Then the gradient of line AB will be equal to 7. Okay. When you use your calculator, you get your gradient to be equal to 7. Then you get you another 2 marks. Now, determine the equation of BE in the form of y equal to mx plus c. Determine on 3.3 or 3.2, sorry. On 3.2, determine the equation of BE in the form y equal to mx plus c. So in the line BE now, what do we know in the line BE? We know that the gradient of line BE is equal to, we calculated initially, it's equal to 1 over 4. Now we want to calculate the equation of this line. So when we are calculating the equation of this line, we always know that y minus y1 equal to mx minus x1. So y1 and x1, it's a point on the line BE. So we don't know the coordinates of B, but definitely we know the coordinates of E, which is 12 is to 0. So we'll substitute here. So what is our y1? Our y1 is 0. Then our gradient is 1 over 4. Then x minus, then our x coordinate of point E is equal to 12. Then after that, we now factorize and solve. So 1 over 4 multiplied by x is 1 over 4x. Then 1 over 4 multiplied by negative 12, that's negative 3. So if you don't know how to just do direct calculation, I advise now is no longer the time for you to dwell much on how to do factors and stuff. Use your Casio calculator. Always know that your Casio calculator is the best way to go. All right. Now, we have the equation of line BE. Now, let's go to the next question. Now, on question 3.3, the question goes, calculate the coordinates of B where k is less than 0. Calculate the coordinates of B where k is less than 0. And it's only 2 marks. So now, what we know about a line BE, we know that the line BE, we know that line BE has a gradient, or has the equation of line which is y equal to 1 over 4 x minus 3. Now we want to calculate the value or the coordinates of B where k is less than 0. So now let's look at this B. B we are given as k is to 2k. So definitely we can just substitute point B, which is k comma k, in the equation of line BE. In the equation of line BE. So that would definitely be our k will be k, then 1 over 4. Then we have x there. Our x now will be k minus 3. Yes. Then now we solve for k. So our k will be equal to, let's transpose 3, so it's positive 3 is equal to 1 over 4k minus 1. That will give us negative 3 over 4k, because we've transposed 1 over 4k, then we transpose k to the other side. So we'll end up having 1 over 3, negative 3 over 4k. Then we divide both sides by negative 3 over 4, divide by negative 3 over 4. Then we end up having the value of k, which is equal to negative 4. So now we were able to answer the question in an appropriate way, because they already told us in the link that the value of k must be less than 0. And we can actually see that when we have done calculation that k is negative 4 and this k is less than 0. So then therefore the coordinates of line B will be negative 4 is to negative 4. Then you get your 2 marks just like that. Okay, great. Now moving to the next point, which is 3.3.2. And 3.3.2, the question says calculate the size of A. Okay, calculate the size of A. How can we calculate the size of A? So now we are told to calculate the size of A. So in order for us to calculate the size of A, where is A first? So we can see that A is the coordinate, is a coordinate negative 2 and 10. So here is our A. Now we must now calculate that. So the first thing we can do here is to be able to realize first thing that we must calculate the gradient of line AC so that we can know the angle of inclination of that line AC. So let's go. Let's calculate this line together so that we can be able to see and get the correct answer. So the gradient of line AC will be y2 minus y1 divided by x2 minus x1. So we are given line AC, so it's going to be 10 minus 2, then we divide by negative 2 minus 4. Then 10 minus 2 is 12. 12 minus divided by 6 is negative 2. So the gradient of line AC will be negative 2. So now let's calculate the angle of inclination of line AC. So as always, tan theta is equal to the gradient of AC. Then our theta will be equal to tan inverse of the gradient, which is negative 2. Then we get our answer. Then our theta will be equal to negative 63,43 degrees. So now we add 180 degrees so that we can have a positive angle. Then we end up having 116,57 degrees. So that will be our angle of theta there. Then after that, now we can now be able to calculate the line of angle A, because that theta now, when you look at that triangle, is going to be the angle of A, X, y. So like that point now will be able to give us the correct answer. So then therefore, for the angle of A, we can calculate that, and we say that 116,57 degrees minus that 81,87, which is the angle of inclination of line AB. Then what's the reason? We can see that it's the exterior angle of a triangle. So Thursday, when we are doing Euclidean geometry, definitely you'll be able to realize these things, that every time you state this is this angle, you must explain why are you saying that this angle is equal to this angle. Why are you saying that when you add these interior angles of this triangle, you get 180 degrees? If you don't write your reason, which means your answer is not valid. So it's always the case. It's always the case. Please be aware of that point. So now we have our angle of A. So now we subtract there. Then that will be 770. Then 83, then we have our 70, 34,70 degrees. So our angle A will be 34,70. Then we are done with that question. Now let's go to 3.3.3. we are almost done today. I wanted us to have like a short session of approximately 30 minutes maximum, so that we can just enjoy of that short time which we have. Then on 3.3.3, calculate the coordinates of the point of intersection of diagonals of parallelogram ACES, where S is the point in the first quadrant. So how will we be able to do that? So we know one thing, that the point of intersection is the midpoint of the function of the whole parallelogram. So let's just calculate that. So we can just use the coordinate, the midpoint formula, which is m x plus x2 plus x1 divided by 2, and y2 plus y2 plus y1 divided by 2. Then after that, we are ready to go. So which coordinates can we use? So we have our coordinates of 12 is to 0, and we also have our coordinates of negative 2 is to 10. So we can use those coordinates. So the midpoint will be 12 minus 12 plus minus 2 divided by 2, and 10 plus 0 divided by 2. Then the midpoint coordinates will be 10, 12 minus 2 is 10, 10 divided by 2 it's 5. Then 10 plus 0 is 10, 10 divided by 2 it's also 5. So the coordinates which we are looking for, or the point of intersection, the point of intersection will be 5 is to 5. Then you get your 2 marks just like that. Now we are moving to the last question of today, on 3.4. Another point T, P is to P, where P is greater than 0 is plotted such that ET is equal to BE is equal to 4 square root of 17 units. Now the first question, 3.4.1. Calculate the coordinates of T. So what are we given? We are given that ET is equal to BE is equal to 4 root 17. So now we want to calculate this point T. So what do we know about point T? We know that point T is a coordinate which is P is to P. And what is the coordinates of point E? What is the coordinates of point E? So the coordinates of point E is 12 is to 0. So now we are given now the distance of line BE to be equivalent to the distance of line ET. So now let's calculate the distance of line ET. So the distance of line ET as always is square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so now let's calculate that and substitute that part. So we will have square root of 12 minus p squared plus 0 minus p all squared. And bear in mind, this must be equal to the distance of ET. And the distance of ET we are given, that is 4 root of 17. So when we square both sides to remove the square root there, then we will have our 272 this side, because we use our calculator. Then we have 12 minus p all squared plus p squared. Now let's solve this. This will be 272 equal to, then that will be 12 minus p multiplied by 12 minus p, because it's the square root, plus p squared. Then 272 is equal to 12 times 12 is 144. Then 12 times negative p is negative 12p. The negative p times negative times 12 is negative 12p. The negative p multiplied by negative p is positive p squared plus p squared. Then we have our 272 is equal to 2p squared minus 24p plus 144. Then after that, we can actually see that now we are getting to something. So 0 is equal to 2p squared minus 24p plus 144 minus 272. Then if we divide all through by 2, we will have p squared minus 12p minus 64. Okay, then we are great and having nice time as well. Now we can now calculate, or we can be able to determine the factors here. So definitely it's p and p. Then when we say 16 times 4, we get 64. So 16 by 4. So in order for us to get that one must be positive, this one by negative. Then we have, then therefore p minus 16 is equal to 0, or p plus 4 is equal to 0. Then our p will be equal to 16, or our p will be equal to negative 4. But initially they say that the value of p here, they say that p must be greater than 0. So we are going to choose the positive p value. So the positive p value is 16. So then therefore the coordinates of t will be 16 is to 16, because that's the value of p which is greater than 0. Then we are getting there, guys. We are getting there. Then now on 3.4.2, determine the equation of the circle with center at E and passing through B and T in the form of x minus a squared plus y minus b squared plus r is equal to r squared. Okay, so that will be easy, because we know the coordinates of A to be 12, 0. So that will be definitely easy. So we know that x minus a all squared plus y minus b all squared is equal to r squared. So what do we know? Our a will be negative 12. So negative 12, because e will be the center. So it's going to be negative 12 squared plus y minus 0 all squared. And our r squared, we were given initial that et is equal to 4 root 17. So by the way, we will have our 4 root 17, then we square it as well. So it will be x minus 12 all squared plus y squared is equal to 4 root 17 squared, and 4 root 17 squared is 272. Then we have our equation of line. Then we are awarded our full marks just because we are able to do that. Just because we're able to do that, we'll be able to be awarded full marks. Now, as we are moving forward to almost the last question of the day, which is 3.4.2, no, 3.4.2b. So 3.4.2b now. Determine the equation of the tangent to the circle. All right. So what do we know about the tangent to the circle now? What do we know? We know that the gradient, which is BE, is the radius now, since now we are not dealing with the circle. So the gradient of the line now, of the radius, will be equal to 1 over 4. So as I said initially, that the gradient of the radius multiplied by the gradient of the tangent is equal to -1. So the radius is 1 over 4 multiplied by the gradient of the tangent equal to -1. So the gradient of the tangent will be equal to -1 divided by 1 over 4. Then after that we divide that, then we get our gradient of the tangent to be equal to -4. Then now we know the gradient of the tangent to be equal to -4. Now we can calculate the equation y minus y1 is equal to mx minus x1. So now our m is the gradient, so we have the gradient, so we can now substitute the point which we think we have there. Okay, so we can use our -4 is to 4 the coordinates of line B, okay, because that's the center point of the, so when we draw, it's going to be somewhere like this. This is our B here, then this is our E somewhere here. Okay, I'm just doing like a typical example. So this is B, which is attached to the tangent. So we can substitute this, so it's going to be y minus 4 equal to -4x minus 4. Then we have y plus 4 equal to -4x. Then that will be -16. Okay, because negative times negative is +4. Then -4 times +4, that's -16. Then our y now will be equal to -4x minus 16 minus 4. Then our y will be equal to -4x. -16 minus 4 will be -20. Then we have our line. So this is 24 marks for 24 minutes exactly. So I'm also urging you, when you are writing that, 3 marks means 3 minutes, 2 marks means 2 minutes. Don't overspend time, don't spend much time or dwell much time on things which have few marks. So recap of the day: today we did analytical geometry for a period of 30 seconds. Okay, the idea was for us to, for 30 minutes, sorry. The idea for us to have it for 30 minutes so that we can assist each other for 30 minutes, 30 marks, 30 minutes. Okay, I hope you enjoyed, and if you have any question, please don't hesitate to ask on the comment section or ask in the WhatsApp group. And have a good evening. Please continue pushing, continue studying, because that's what we want. We want great results, and we want you to be fully equipped so that you can have access to the university. Till we meet again, have a great evening.